Is it recording?
Yeah, looks like.
Okay. Okay. Yeah, let's start with yesterday's review. And what are you seeing? Are you guys seeing the screen? My VS Code?
Yeah, VS Code.
Okay, cool.
Yep.
Let's start with yesterday's. Okay, so Lavo asked that what are all those arguments here? So, April, you want to give it a shot?
It said too many arguments in the VS Code. It's like a red squiggly line. It's on example, I want to say example 3.
Yeah, this is example 3.
Yeah, example 3.
Yeah. So you're talking about this portion right here, right?
It's line 22. It's line 22. No, on my thing it's line 22. I don't know. It's under
Okay, Lavo, does any of this look similar to what you're asking? Do you see?
No, it's on example 3. And example 3 is like, yeah, that one. So down here where it says null on 22.
Here?
And mine is saying too many arguments.
I had the same thing. Yours probably in the solution code, it's just wait. If you change it to wait PID, that will get rid of the linting error.
Oh, the PID.
Yeah.
Yeah, that did.
So it was just a typo?
Yeah, it's just missing the PID.
Okay, cool. All right, thanks. Oh, by the way, talking of processes, if you want to see what processes are running on your computer, let me go to the other one and then I'll just open it. Let me open what I was going to talk about today. Okay. Okay, so if I'm on any terminal, Bash, Linux, whatever, if I wanted to know which processes are running in my computer, if I just type top like that, it brings up a screen and it's going to tell me like all the processes I have running on this computer. And then it's swapping them out. It's just like what we talked about yesterday. So you see the PID, it's slapping IDs on them. So it's got all these IDs here. And then it's got the commands. So, and then it's giving them time here, and it's got all kinds of stuff. And as you see that, like switching out, it's got all this information running on top.
What about when you put top space -u? Because I usually do -u. What is the U for?
Yeah, those are extra commands. I don't know. But okay. There are all kinds of commands you can do. We can try it.
Yeah, because that's what I usually do. Looks like the same thing.
Yep.
I think the order of the process identifiers are different. Because in just the first column. The first time you ran it, everyone was in order.
Okay, so let's okay. You see all the IDs are all like out of sync if we stop the process and just do top. These seem to be in, oh, not really.
Oh yeah, I guess they're not. But they are all grouped in the 30,000 range.
Right. I guess the ID is different. Oh, it's picking out the top ones. Because you see these IDs
They're in order.
Yeah. Maybe going
It's the-
downwards? Yeah,
yes.
decreasing, yeah. Okay, yeah.
Uh,
All right, okay. Now let's come back to today's lecture. I'm gonna review JavaScript, Python real quick before we jump back to C, because some things we did in JavaScript, Python, that might help you out in C. And specifically map, filter, and reduce. Right? So if I created a function, I'll just call it JS functions. This is gonna be so easy, so everybody should be like contributing. And then once we go to C, we're gonna see how this will translate to C real quick. Okay, so if I've got a list of numbers here, and it's gonna just say 1, 2, 3, 4, 5, 6. If I've got a list of numbers here, and then I want to say double it, what function am I going to use? What am I going to do to the numbers? What function, what JavaScript function am I going to use?
Filter?
I want them doubled.
Oh, okay. You
So
want to double.
So what function am I going to use? Not filter.
Map. You said map, filter, or
Map.
reduce.
Yeah,
so
map.
if it's not filter, then it's map.
Right. Okay, so map, right? Element. And then I'll just double the element, right? Right? And then if I console log the double, I never saved it. You see, they're all doubled, 2, 4, 6, 8, 10, 12, right? What if I just wanted evens?
That would be filter.
Yeah. Right? Actually, do key equal to 0. And that gives me even, so odd will be the other one, other way around, right? It's complaining. That's just something I can say. That here. And then odds, it's going to be the same thing, but without equal to 0. And then we can display that here like that. See, evens and odds. Nothing too fancy here. But who knows what's going on behind the scene? So we've done map, reduce. Okay, now let's do reduce. If we want to add up all of them total, how are we going to do that? Nums, reduce, right? Right? Right?
Yes.
Okay, and then element, it takes in the accumulator, and then the current one, and then an optional index here, but we don't need it. And because we are passing in multiple arguments, we have to put it in parentheses, and then the return value is just going to be element, accumulator plus current. And then if we console the total, the total is 21, and you can tell 11, 15, 18, 20, 21. That's the total. But we can pass in an optional starting point. What if I wanted to start at 30? Then the total should be 51. So 51. Any of this, like, that's just simple JavaScript review. Now, what's going on behind the scene? If we had to write our own filter, reduce, map, how are you going to do this? So for example, if we wrote our own map, the map function is going to receive an element. Actually, in this case, since we're not attaching it to the array, we literally have to pass in the array itself. Actually, it only gets the array and the index. And a callback. So we're going to pass in the element in here. Let me then call them elements. And then we're going to pass in an option callback, because the callback is whatever we're going to do. In this case, if we want it doubled, we're going to pass in a function that doubles in the element. And at the end of it, we know this returns an array, so we'll need a new array inside. And then we're going to do something using the callback, and then we'll return the array we just created. And here, we are going to repeat doing what the callback wants us to do, but on each element. And we are going to do this by looping through all the arguments that were sent in with the elements. And we definitely want to do some action on there. On the item, and then we want to add it into the new array. So like that. And the callback, we pass in the elements item, like that. And then if we use it, for example, we have nums there. We're gonna say another.
What's up, man? I'm all right. They still got me in class. You all right?
Another doubled.
Damn, what time?
We're going on passing
You left hella early, huh?
the nums
Yeah,
and also the callback.
Yeah.
And the callback, we're going to pass in this function, which in this case will return.
No. Do you happen to have an extra AA battery I can buy for you guys? Anyone?
I don't think I have one.
Yeah, we're going to pass in an element here.
I could check though, but I don't think I have one.
That's fine.
Whatever we pass in, we're going to say element times 2, and that's returned.
I have lots of quarters over here.
Yeah. I got a few over here.
As you can see, we implemented our own map function here. Our map function here, which we pass in our callback function here. And just to make it easier, I'm going to use arrow function so that this is almost the same as the one above. And if I use arrow function, I don't need the return statement. I'll just write it like that. And if I did that, it's still doubled. Any questions? This is just a review. We've done this in JavaScript before.
Yes.
I'm good on it. I studied it for a little while when we were doing the list, or the something. We were doing something recently that I was looking it up.
Okay, cool. Given that, so let's now then do our custom filter. Now, since I did go through the map, you guys tell me what to type in filter. Guys, join it.
All right, let's pass it elements and callback. And then we want to do a new array. So yeah, the difference is going to be, we're going to do another for loop, but the difference will be what we do in the for loop.
Elements.filter, right? Dot filter. Oh no, okay, dot length. Okay, I'm wrong.
Well, this is our custom filter. So now, Andrew, you said the difference is going to be here. How is it going to be different?
I guess we're removing elements, or are we picking elements out with filter? Okay.
So we're only passing, like we're going to be doing a callback still, but we're only picking the elements that pass our callback. And in this case, we'll use an if. That's the easiest way to do it. So
Okay.
if you do a callback on the element and it passes, then we can add it to the new array, right? That's the one.
Okay, yeah.
right?
Yes.
Now, what's another way of adding something to the array?
Yes. Those I was. Push.
Yep. Anybody has a question on why that works? So we're literally like going through almost all the array methods, JavaScript functions, methods. So we've gone through push now. We've gone through physically, manually adding an item to the array. We've gone through map, filter, reduce, kind of like a quick reminder. Cool?
Yes.
Yeah. And then let's test it out. This time we're going to say greater than 10. So we're going to call our filtered function. Actually, it's not going to work since our numbers are not greater than 10. So greater than 3. Greater than 3. So we're going to pass in our nums. And then we're going to do our callback. And then I'll just go straight to the arrow function.
Mm-hmm.
And in here, we're going to say element greater than 3. And then we can check it out. And it returns our list, 4, 5, 6. Those are greater than 3. Right?
Mm-hmm.
Okay, now let's implement reduce. All right, let's go. Quick.
Element.
Callback, right? And this time we can have an optional starting value.
Mm.
Right? And remember, this one always does like kind of like something you always return. Like it always remembers something. So what we can do is, if somebody passes in a starting value, we're gonna give it as a memo. We're gonna store it as a memo, and then we're gonna check if someone has provided a starting value. If they haven't, we're gonna use the first element in the element, right? And then what's the method for like remove? Because once you grab it, you don't want it to be still in the array. So you want to remove it and put it in the memo so that when you start looping on the second item. So what's the function of, first of all, we'll just do an if check to check if memo has been provided. And the easiest way in JavaScript is if it's undefined, because if starting value is not provided, it's going to be undefined. If it's undefined, we want to call the method of removing the element of the first element of the element. What method is that? Variable. So we talked about push, and then what's the method of removing like the first item of the elements array?
At the top net.
But in JavaScript, shift. Yeah. So we're going to shift it off the array, and then we're going to put it into the memo, so that we can work with the memo. So this is dynamic. If somebody doesn't provide a starting value, you can just pop the first one off, and the array will still be correct, because when we start looping from the second element, and the memo already has a value in it. So memo of the elements we shifted on, and then we're going to loop through all the elements. Any questions about what I just did?
I understand it.
Okay, cool. So we're going to look through the elements. Okay. So the elements are now reduced to all of them. And then memo, this time, every time something happens to the callback, we're gonna make it the memo. And then we're gonna do a callback with the memo passed in there and with the element. Like that. And then what did we do earlier? We did a total. So we can call it. We can call it. Reduce. And then in our reduce, we're passing in the elements, nums, and then we're passing in the callback function, which will have an accumulator with the type. And in this case, we just accumulator
Plus
current. Yeah, and then we can comma that and start at 20. First of all, let's just do it without that. Console that. We did not return the memo. We need to return that memo. So it's 21, that's correct. But we can optionally pass in another one. Let's do 10 so that we know it's going to be 31. So 31. So our custom functions are working quickly. Now, if we did this in Python, this time I'm not going to go through the custom thing. We'll just be literally using the Python methods in there. We're going to kind of like repeat the same thing, but it will be faster. So we're going to say py function. Okay. So can you give me, if I had two numbers, x equals 4 and y equals 5. Can you show me how I can write this as a lambda function to return the total?
lambda function.
Oh, are you guys familiar with lambda functions?
I remember them from like a couple coding challenges, but that was about it.
Okay. So A lambda function, in this case, I'm going to call it sum, is equal to, first you have to tell it that it's a lambda function, and then you have to tell it the arguments you want to pass in, and then you have to do a full colon, and then whatever expression you want to do on the other side. So in this case here, if I want to add the two x and y, I'll do something like that. And then to call it, I just call the sum, passing in the arguments. It changed it to definitions. Okay, it's kind of like making a function, but it's because of the way we wrote our program. It wants let me get a boiler starting point from the web. So it's my compiler, like all my VS Code saying now you have to kind of like write it properly. Since I just wrote out some Python on one line. Okay, there we go. This is a starting point. It wants that main function there. And then we'll just say functions. And then now I can put everything in functions, and then everything we do is gonna go in here. Okay, now I can, first I'll test it out that it's working. Okay, so it's working. So whatever we start doing, it will be popping out here. Okay, now let's talk about lambda functions. So like I said, if we wanted a lambda function sum, we'll do sum equals, we call it lambda. Then we give it to the arguments. So I'll give it 3 arguments just so that it's a little bit different. And then you can do whatever you want with those arguments. You can like sum them in this case, since we called it sum. We can also have like a lambda function for product. It keeps changing my stuff. I think I know why it's changing it. Yeah, it's going to change it. The reason it's changing it is you want to use lambda functions as anonymous function. So like you want to pass them without a name. So it wants them passed in like that. That's why it's refusing. But you get the point. Do you get the point though? Or is that confusing?
So the lambda is a built-in function, basically.
Yeah. So this is a built-in function which says lambda argument expression. Now, knowing that, there are other built-in functions in Python. For example, filter. Filter, you're going to pass it a lambda function. That's going to get, in filter, in this case, it's an element. So if we want to say, odds, in this case, we're going to say a lambda function, which has the argument x, and let me say element. So that makes sense. And then we're going to say element divided by 2. This is the expression equals 0. This whole part, you understand that's for evens, right? And we're passing in the element here. And this time, we have to pass in an array as the second argument. So we're going to pass it in as element here, and then we need the elements in there. And that's just, we'll use the same list as before. Okay, so elements is the list of these numbers, which we pass in as the second argument here. But because of the way the filter function is in Lambda, in Python, we need to like process this in terms of a list. So we have to return a list like that. Okay. There we go. And then if we printed out a new list as that, and then we printed out the new list,
you missed the parenthesis on line 3 at the end, closing it.
yeah, right. Okay, so that returns evens. So here is a new concept. So the lambda was just a new thing we learned, but the rest of it should be pretty familiar. A filter is filtering out this element, and whatever you get, you have to cast it back to a list. Because if we don't do that, we're going to get like an object with some stuff in it. Just to show you guys that if I remove list here, and then I printed it out. So you get this object thing. Do you see that?
Yes.
Okay. What about reduce? So that's filter. What about reduce? How are we going to do reduce? We're just going to use the same reduce, and then we'll call lambda. In this case, we're going to have the accumulator and the current, right? And then full column, and then it will just be acc plus current. And then if we printed that total thing,
21. Oh.
Okay, now, sometimes you have functions like this one, which doesn't exist. So because it doesn't exist, you have to import it from, like quickly just import it from function tools, and then you just import the function that's not there. And then if you run it, oh, I didn't pass it the nums. Okay, so 21. So any questions about that? So we were attempting to use reduce. We found out that reduce doesn't exist in this Python repo or whatever. So we just imported it in, like one function out of the function tools.
Mm-hmm.
Right, and the rest of it is just the same template. What about filter? Okay, we did filter, reduce, what else? Map, what about map?
Map.
It's gonna be
Total equals map.
all right, so we're gonna say, yep. So doubled equals map. And because of that, it tells us the map exists. So we're just
Like
gonna double.
we've been doing these lambda functions. It's a lot easier.
Right. All right. And you know to multiply okay. This time let's square the numbers. We've been doubling them up so that you are exposed to more things. I'm gonna square all the numbers, like the square root, instead of doing like to the power 2. In Python, you have to do 2 to. Actually, let's triple them. Triple. Cubed. Cool. Cubed. All right, and then if we, okay, now I'm gonna do this so that you see that you constantly make mistakes, and you have to test things out, and every time you make a mistake, you fix the mistake. It's faster, you learn better that way. So I've made a mistake, but I'll just print it out, and we'll see what's happening. Okay, let's see. Who spotted my mistake already? See, it returns an object.
You have to return it as a list.
Cool. So those are the 3. Okay, and this is killed. 1, 8, 27, 64. 1, 2. So something else. So that's map, filter, reduce. Now, the reason I was doing all those here is I wanted, because somebody had a question about the callback functions in C, and how that was like, I'm still having difficulties. So now we're going to now transfer everything we've done in JavaScript, in Python, over to C. Ready for that? So
No, we could just leave it just the way it is. It's fine.
Yeah, that's gonna help you understand some of the concepts behind there. I know he did reduce in class. So reducing class is exactly the same thing. So we'll just copy the one in class, and then we'll work off that for map and filter. So the one you had in class, so you did a reduce.c. Okay, this is the one you had in class, right? And the GCC. Okay, and then if we run it, reduce. Okay, so 14 and 90. So these, the sum comes to 14 and the product comes to 90. Okay, so the parts of this function. So the standard IO, that just enables us to do things like printf. The standard library, it enables us to allocate memory. So whenever we want to do like malloc-in. So here it defines the function pointer to a reduced callback function here. And in C, because of the complications of type system and stuff, we are going to have to give it an int. We're just going to work with integers in this case. So with JavaScript and Python, you can literally work with strings and all kinds of objects. You can play around with that stuff. But we'll just keep it simple and work with integers. So a reduce as an accumulator, a current one, and then like this is a callback function called sum, and another callback function called product. And then is defining the reduce function, which it passes in the arguments, like the way we were doing it in JavaScript. And because of C, the common practice is to give it the length already, and then it has the memo, and then the callback function itself. And then the accumulator is grabbing the memo here, kind of like what we did in JavaScript, where we are storing the memo, and then we're looping, and every time you loop here, you're like making you do a callback, you pass it in the previous accumulator, here you pass in the next argument, which is the current, and then whatever you get out of the callback, you put it into the accumulator, and then you just return the accumulator. And then if you look at that, it's almost the same as our reduce function. Almost, but it's doing the same thing. As you can see, the memo is receiving whatever is returned from the callback function, and the callback function is having a memo passed into it with an element, current element, and returning the memo. Almost the same thing. See that? And then here you have an array, and then you just pass in the reduce function array and run the sum. Pretty cool that you can do this in C that we did in JavaScript. Now, knowing this, let's do a map function. Okay, what do I need? Max?
You're going to need something to take in an argument. So
No, like we're doing C, so we need the framework for working with it. So we have to set up the skeleton.
it's like type of.
The first thing is we need
You need to import the libraries. So
right. What other library do we need?
Standard lib.
All right, and then we do a setup, right?
Your main.
In C, the common practice is to put the curly braces in line like that. All right, so we do have that. Right, now we need to define the map callback, right?
Yes.
Type div And we're just going to work with with integers. So I'm going to say map callback definition, which is going to receive. What is it going to receive?
It's going to receive like an argument, so like a current.
Yeah, current. We'll call it current. And I'm going to pass it in an integer, or just in case in the future you're doing something that requires the int in there, you know, or the spat in there. If you're doing some crazy mapping where it needs to know what the index is for it to do something, I'll just pass it in there. You don't have to use it. All right, and then we're gonna now write our reduce function. But since it's gonna be returning an array, in the reduce that it did, it just returned like the total. So it didn't have to, like, it just returned an integer. But in our case, we're gonna return an array, right? Because of that, we have to return a pointer to the array. So you're not returning an integer, you're returning the pointer to the array. And we give it the name map. The same way we pass in the arguments. We're gonna say elements. And then we're gonna pass in the length of the element. And then we're gonna now use the map callback, right? And because of that, because we're returning an array, we have to initialize a new array here, and we have to give it space. So we're gonna give it some memory, and we're just gonna give it the same memory as the coming array. And the easiest way, we already know the length of the current array. We're just gonna use that, and then we're gonna do the size of. We can use the first element in the array, but it's just okay if we use the integers, since we're working with integers anyway. And then we'll return it. We'll return the new array. What's there, right there? Okay, there we go. And then now in between there, we're gonna do something with each element. So it's the same procedure. We're gonna loop through, and here I'm gonna be explicitly, instead of using I'll use index, so that you guys, when you look at it, you're not like, what's the I doing? So we're gonna loop through the index of the elements coming in. And then every time something happens to it, we are going to like physically put it in the new array. And the easiest way to do that is to say the index of that spark equals to the callback. So whatever's going to happen to the callback, and then we're going to send in, the callback is receiving the current elements, so which is the elements at that index. And then since this is receiving the index too, we might as well just pass it, we'll pass it in. So that's set up. So we've written our map function in C. If you go back to JavaScript, that's the same thing. So we start a new array, we loop through it, we return the array. But in C, because we have to keep mindful of like the memory stuff. So our new array, we're initializing it as a pointer and then allocating some space to it. We know we're returning an array, so we're returning a pointer to the array. and then we just return the array here, which is exactly the same as in JavaScript, except here we're just being mindful of what we are doing. Any questions?
Nope.
Makes sense?
Yes, makes sense.
Cool. So it's not as bad as you thought. It's almost the same as JavaScript, right?
Almost.
All right, now we need a function. What do you guys want to do? So we've got double, cubed, we can add one, we can do anything. So I guess let's do double since that's easy. So each time you double something, you're returning a single element. So we just go an int there. So double, it's going to receive a number or an element. And also, since we have to pass in the index here, and then we just return the number doubled, right?
The element?
Element, yeah. Okay, and now we have to use it. So we're gonna have the same elements we had, which was, okay. Now in C, remember, this is how you do arrays in C, 1, 2, 3, 4, 5, 6. Right?
Mm-hmm.
All right. Now, Andrew, is Andrew here?
Yep.
Andrew, okay. How am I going to get the length of this array?
Multiply size of elements by size of int, or by the first index in elements.
Okay, so whenever I'm doing stuff, I like to test them out. So I'll do print f bar length is, before I go further, because I'm, okay, let's see. Okay, all right. Okay, I'm not choosing that. Maybe I should have. Okay, anyway, let's see if it works. The length is 6. Cool. Okay, that's one way of doing it. What's the second way? Okay, you can do elements here. The first one. That's fine. But what's another way? Do you know another way?
No, off the top of my head.
I was shocked when I learned this. It was actually awesome. It's the first time I saw it, I was like, wow. Okay, so pretty much you're getting like a reference to the pointer. You get kind of like dereference that, and then you just subtract the array itself. Oh, okay, sorry. You have to add 1 there. So like you go to the pointer, you add 1 there, and then there, 6. I was stunned. I was like, what the hell is going on here? I had to, I asked Sean and Paige, they had to explain it to me.
And
I have to just share the explanation with you guys because it was awesome. I mean, I did a good job. So. Okay. I'm just gonna prepare. It kind of had like a multi-statement. So you just have to read the user explanation. Okay. Okay. Yeah, I'll post this and you can read it out later. But anyway, I thought that was cool. Okay. So we've doubled, or we have our array, we have our length. Now we need a new array to hold whatever is doubled. So this array is going to be an array of integers, and then we'll call it doubled elements, which is just a pointer. And in this case, it's gonna, now we're gonna run the map function. Doubled elements, and then we're gonna run the map. And then we're gonna pass in the elements up there. We're also gonna pass in the length, and then we're gonna pass in the function, the callback function we're running, which is doubled. And then to see our result, we have to just print it. Print f. What I'm gonna do is this. So I'll first print f. I'm gonna print like a curly thing, brackets there. And then I'm gonna print f, a closing curly brackets like that, and then I'm gonna start a new line. Then in between here, I'm gonna do a for loop. Where is it? Oh, okay. I'm gonna do a for loop to loop through the arrays. So for I equals to 0, I less than the length, because the length is the same in the for loop, I mean in a map, I++. And then I'll just print out the element. Print f. And we know it's integers. So it's d and then comma, space. And then we'll say dashboard elements index. Okay, there we go. And then we can compile that. It's complaining. Okay, so you see that 2, 4, 6, 8, 9, 12. And then we have this space here at the end. So we can do like a logical, just to make it look nice. If I is equal to length, we're gonna display this. Actually, I can move this display here to there. And then I'll just copy that. I don't need that. Else, I'm going to display the other stuff. And then and by the way, since we're not using the index, I've explained that sometimes you want it. I'll just take it out. Yeah, I'll just take it out completely. Since we're not using it. Oh, I forgot to pass in that. Here, since I even know that's error, I can literally just do this. But just in case you copy and paste later on, you want to use the I there. There we go. Okay, forgot to do the new line. I is equal to -1. Because it's never gonna be error. Okay, there we go. See that? What do you guys think about this? Albert?
Yeah.
What do you think about this pulling off a map function in C, which looks almost the same as JavaScript?
Yeah, it's pretty cool.
Does that help with callback functions?
Yep.
Cool. All right. So pretty much filter is going to be the same. So we're going to go fast in this, except filter, you're going to be changing the array size. So you have to be careful about that. Because here I was using the fact that the map always uses the same length as the previous one. But with the filter function, you have to kind of like reduce the array size. So that's tricky to do, but you can pull it off. Okay. Obo? Obo? Obo?
Yeah.
Hey, so we're now doing a filter function. So what do I need to, like, what's the bare bone beginning of it?
Oh, you gotta include your standard IO in your standard library.
And then what else?
Did you want to do, do the main.
Okay.
And then you want to do the type div int. Get you just call it filter with a pointer, an asterisk, yeah. And an int current, the int current and an int index.
Yeah, but we might not end up using it, so we might as well ignore it here.
Yeah.
Okay, and then? April, what else? April?
Sorry, my husband just got home. I wasn't paying attention. I'm trying to think. I'm not 100% sure what comes next.
Yeah, we'll just call it filter.
Okay.
Right? And then why am I putting an asterisk here?
Because that's a pointer.
Right. Why am I using a pointer though? Like, what's the reason? Why can't I just do this?
Because you have to point to where the information is going to be stored.
Because I'm returning an array.
Okay.
So if I'm returning a single number, I'll just do it this way. But I want an array, and in order to do that, I can't return an array, but I can return the pointer address to where the array lives.
Okay.
So, yeah. When you do that, I'm returning a pointer.
Okay, right. I knew it was a pointer. I just wasn't sure where it was pointing to.
Right. And then what else am I passing in here?
The current? Oh, no. Yeah, no.
Elements. We need the elements to work on, right?
Mm-hmm.
And then what else?
Then the current, or not the.
This is we're defining the filter function. So the current is going to go into the callback function. So length, yeah. And then we have to call the filter callback, right? And all right, now we have a problem. We have to kind of know the return. Here we're passing in the length, but we don't know the length of the returned array. And the reason they pass around the array length like this is it's really hard to maintain the length of an array with great accuracy, because if you're moving from one function to another, so it's just easier to send it with a length. Because of that, we're kind of like going to be passing on the length of whatever the array is. So I'll literally like just pass it in, because if I don't, or the returned length, because if I don't, I'm going to have a problem. And the way I'm going to do this is I'll have like the length stored in the main program, and then pass it in there, and then I'm going to like increase it in the function, and then return it. I'll be increasing it, but since it's pointing to a pointer in the main function, that the value of that returned array is going to it's going to change. It's going to be changed by this function, but I can still access it outside the main function. Remember, we're using, whenever we're doing mapping, we were kind of like still using that stuff under here. So I want to be able to use the length of the returned array. So I'm kind of like changing it in this function, but still able to access it outside there. And the way I can do that is I'll just pass it in as a pointer here, but still be able to change it outside the function. This is how I'm going to do it. I mean, if there's a better way of doing it, yeah, but this was the easiest one for me. Okay. All right, and then the other thing is the same. We initialize a pointer to a new array, which needs some memory, and we'll yeah, this worked. Okay, we're just going to give it enough memory as the coming in array, but yeah, we're just going to access, like the rest of the other memory will just be rubbish, but we would like give it just enough memory, you know? Oh, we can be reallocating the memory, but that's a lot of work. So it's better just to give it a bunch of memory, which is enough to cover everything out. And we'll kind of just do it the same way as the map function we did. But there's probably a better way of doing it. But in this case, we'll just give it this amount of memory. And because of that, I'm gonna track like the index of the item that I'm putting in there. So there will be like one index for the coming array, and then I'll have another index for the returning array. So I'm gonna, like the two arrays are gonna mismatch in their index, because remember, we're just picking the things we need, and then we're gonna be putting it in the new array, this array here. So I'm gonna track that using an I, and then I'm now gonna like loop through the coming array. I'll loop through all the elements. And then the same thing, we only add items to the new array that has our callback. So to do that, we use an if statement, just like in JavaScript. You see here, whenever we did a filter, we only added items that passed our callback function. By the way, this needs to be elements and that index. Okay. And then if that passes, I'm gonna put the ith index, the index for the returning array, and then I'll pick off the item from the incoming array. And then I need to increase the I, and then the returned length, I'm gonna change it. So once that increases, the returned length is now I. So like the new I. So that's how I'm gonna change the returned length in here, but also be able to access it outside. And then the last thing we do is just return the array. So this filter function, like JavaScript, it's almost the same. Return, you create a new array, you return the array, you only add stuff which passes the callback function. In C though, we are tracking the index, we are using a pointer for the new array, and then here we're kind of like changing the return length. We're keeping track of the length in here, which we'll use later on. And let's do a filter odds, I guess. Yeah, actually, let's try a few like functions. We can do evens, which will return a number or element. And then you return if that element mod 2 is equal to 0. The odd is almost the same thing, but this time we'll just say the modulus of that, and then we'll say bigger than 2, 3. We'll say element greater than 3. And then we can now start using them. So int elements 1, 2, 3, 4, 5, 6. That's 6 items. Actually, we can just do this. I don't have to worry about that. 1, 2, 3, 4, 5, 6. And then the length. Because I thought today's thing was cool, I'm going to use it again. I thought that was the coolest thing. All right. Okay. Now, since we have 3 functions, I'm going to init 3 pointers, even, okay, even array, or array, and then the big array. Okay, and then return the length. I'm also going to init them here. I'll just copy that, and then I'll put the length here. And I'll start them at 0. Okay. All right. And then I'm going to run the functions. We'll run them one at a time. So we'll run that one. Even array equals, we're going to put it. Then we're going to pass in elements. And then we're going to pass in the length. And then we're going to pass in. Now, if I pass in a length like this, it's passing in the value like that. But if I want to pass in the pointer so that I'll still be able to access it here, to pass in a pointer is passing in with an ampersand. So I'll pass in that even array length. So I'm passing it in as a pointer, but I'm able to still access it here. And then since we want evens, I'll run the function evens. Okay, there we go. And then because of
What's the
everything.
ampersand in front of the even?
Yeah, I'm passing it in. Oh, okay. Yeah, you're right. Yeah, because it's I was creating a pointer here, but I need the value, but I need to pass in the pointer of this value here, right?
Could you write a little note on the side that that's what the and sign, the ampersand is? Yes, please. Thank you. For us with old memories.
Okay. And here I'm gonna just copy the formatting here.
Tisk tisk, no copying.
Okay, right. Okay, no, you're right. You're so right. So for
I'm only kidding. You could copy. You could copy.
no, that's literally bad practice to copy. It's true. It's bad. So okay, I'm gonna break that today because this will be a lot of typing. Sorry.
It's all right.
Okay. So we are looping through the integers, and then we are going to use the event array here, and then here what happened? Even array length, and then we're going to check here. It's even array length. Okay, and then here we are. Wait, what? Did I screw something up? Okay, and then we'll say even array there, and then we'll do even array. Man, I screwed something up. What is it? Okay, you see why copying and pasting is bad? I copied inside some, so it was all screwed up. All right, that should work for one of them. Let's try this. Obviously, those two functions are not. Wait. Okay, bigger. Wait.
You took the pointer sign off the big up there. So now, and you made it into the ampersand on the other thing. So I don't know if that affected anything when you took off the pointer sign there.
Let me see if it compiled though. Yeah, it says it compiled.
Okay.
Even array length. Even array length. It's not even printing anything. let me print something here. Filter, extra, oh, filter, oh, okay. And then dot filter. Okay, so hello world is coming up here. So it's working there. Is that function evens even correct? Evens element divided by 2. Mm-hmm. So 1, 2, 3, 4, 5, 6. So it's coming here. Okay. So in here, something is breaking down somewhere. Let me know. Okay, I think I know what's happening. Okay, yeah, this is the problem here. Here we have a pointer that's coming in. So in order to change the pointer value, we have to dereference the pointer to say, I want the value to be this way. That was my error. Yeah, that was the error. Crap. Yep, so now it's gonna work. Okay, so I need to delete something. Okay, so you see that evens 2, 4, 6. So if we did odds, just copy that. I know. And that, okay. I'm gonna run all the functions now. I know. Major break. But that's a lot of repetitive things. So evens, odd, and then big. Bigger than big 3. I'll just say big 3 so it makes a little bit of sense. So this one's running odd, and that one bigger than 3. And then we're going to say print f odd even numbers. Odd numbers. And this one will take in odd. Right? Odd. And then that's going to grab odd. And then that's going to grab odd. And then this one. Numbers there and 3. Big line. Big one, and then that's big 3. All right, if we don't make an error typo somewhere, this should work. Yeah. Okay, so hello. What the hell? Even numbers, odd numbers, numbers bigger than 3. What? Okay, evens is working. Odd numbers retain 0. Ah, there we go. We passed in the wrong thing. We need to remember. We need to pass in the array there. So it wasn't changing. It was still like at 0, but everything was fine. Yep. Okay. Even numbers 2, 4, 6. Odd numbers 1, 3, 4, 5. Numbers bigger than 3, 4, 5, 6. See how cool you can do this? Anyway, any other question? I'll stop recording here.
Are you gonna push this into repo
Right.
or something?
Yeah, I'll move all the functions into the. Yeah,
Please, because I understand it at the minute, but I won't understand it after we're done.
Okay. Cool. Let me stop. Yeah, first let's talk about today's work. How's the typing and the commenting going?
It's going okay.
I personally, I'm still typing, and then I'm gonna go back and put all the comments in. I'm still got to do 4. I mean, I'm on 5 right now, so.
Nice. All right. Any feedback on this week? My style, or us doing lecture style in the afternoon? I really wanted to go over these filter functions because sometimes, like when I talk to you guys, you're rushing to use them without like somebody will be like, I want to use that for each. So I'm like, okay, you have to know why you're using it, like what's going on behind the scene. So as you can see from Python to JavaScript to C, they're literally almost the same, identical, but it's just how you use them.
Yeah, some similarities for sure.
Which one is easier, Python? I know. Yeah. Which one do you think is easy?
I don't know.
I like JavaScript. I do not like Python. Python is too organized for a disorganized human.
Yeah, yeah, that is that one thing where you got to have it all the way correct.
Harvard, what do you think about C now, like with all the functions and stuff?
Yeah, I've from day one I've felt I've enjoyed C the best because of the rules, because of the strictness. So least I'd probably say Python the least for that exact reason, just because it's super loose.
Cool. Maribu?
I just wanted to say that I like it how you're showing us the different languages, like for one function. And yeah, I'm having difficulty with Python as well because I feel it's a bit loose. And sometimes I get blank when I see Python. Like, oh, okay, what should I do first?
Right.
But so, and with the C, it's more strict, and I like the structure, and it's very like a close cousin to JavaScript. So I like that, and also the comments is really helping me better understand. So I really like the comments. I should have done this at the start. So,
Oh, yeah. This is a shortcut to get you all caught up. Literally, I was trying to figure out a way of like making everybody at least do so. Sometimes what happens is if you come across a really difficult concept, you pretty much say, I don't want to deal with that. You give up. But even if you don't know what you're doing, if I force you to type it out, your brain will pick it up. And I used to do that a lot when I was in school. So I would like come across something tough and I'll just like, I'll just write it out or do something with it. And then at the end of the day, I'll be like, oh, okay, I kind of somehow know what I'm doing. So because of that, and it doesn't require anything else to, like anything additional to do. You just have to do the work, and that works. And that's why I'm making you guys do this. You will, at the end of 4 weeks, you'll be like, oh my God, I know how to do this. How? Things are just going to be coming to you like that. And Andrew, what do you think about this? Oh, especially today.
I like this. I really appreciated breaking down how these functions work because they've been. I like the explicitness of C. It really breaks down everything that's happening, what everything is, and how it works in the lowest level. It's very interesting. It's kind of like the polar opposite of Python in a way.
What about Lambda functions? Like, do they look intimidating? No.
The Lambda functions are still kind of weird. I was actually, when I was following along with you, I couldn't get my the Python file to print out anything. I'm not sure why. But,
are you getting anything in your terminal?
No, like when I would run the program, it would just like pop a new terminal line. It wouldn't print anything out.
Oh.
Yeah, I went into the shell and tried it again, and it didn't do that either. So I'm not sure. I couldn't even get like a hello world print to show up. So
okay. After this, we might just try. It's something small. It's not something big.
Okay.
You might be just doing something off. We can get in a Zoom and talk about it. Hey, Max, what do you think about this stuff since you've been here for 2 days only?
I actually really enjoyed, particularly today, I really enjoyed kind of seeing the contrast, seeing between all the languages, and it made me actually probably like Python more than all the other languages. I'm going to break with what everybody else said. Everybody else loved C, and I still don't like C. It's very tedious.
I love JavaScript. Look, like all that can be broken down to just these, like that. That's amazing. Like down here, it's just those 3 lines.
Like C is so verbose. So many lines of code, and it looks unwieldy, and I just don't like the way it looks. I said.
Yeah, but if you can do this stuff like this, and then you are now working on like creating new computers or new gadgets or some idea you had in your mind, I mean, you would want to do stuff like this because it's going to give you control, like a lot of control.
I can definitely see, I can appreciate C. I just don't like it.
Over, any feedback?
Oh yeah, yeah. I was starting to like see a little more. I feel like today, a few concepts began to make a little more sense. But overall, I still think JavaScript is way better than the other two by miles.
And finally, Hero. Any feedback? And then we'll.
So, I think it was Python map, and it printed an error message with hexadecimal numbers. So the moment it kicked in that this is the pointer in C, and what we did was making it list. So the element in the list printed out correctly. So I think what I learned from C helps me to understand what is going on with Python and JavaScript and any other, high-level languages. So yeah, it really helped me, and especially today you showed me how the C works really. So yeah, it was really interesting and really helpful for me. Thank you. Thank you, Edward.
All right, I guess with that, did I miss anybody? Lavo, did you give your feedback?
No, I didn't. I like the control of C because it's like we can control it and see exactly what it is we're doing. JavaScript is just, it's so popular. Like, I like it too. But Python, I just don't like the syntax because it's like I have something missing. I don't know where it's going to go. And you have to figure out where you put it on what line. So I don't really like that. But the C, I like C. I just need to get more familiar with it. And JavaScript, I like it. But I don't know, between C and JavaScript, I'm not decided yet.
Okay, cool. Yeah, for me, it's JavaScript. I hated JavaScript, hated it. But once we started doing things like this, I was like, oh my God, this is awesome. I'm in love with JavaScript. All right, with that, I'll let you guys go back to your work, and I'll code review your stuff later tonight. And I'm gonna post a solution video around like 1 hour from now.
Okay.
Yeah.
Back to work.
Cool. Bye.
Thanks.
Did you want me to stay in here, Edward?
Yeah.
Okay.